RCC's Math Tape 075, Translating Sentences into Equations. As we go through this material, you will be expected to know already how to translate words into mathematical expressions. If you need to review this, you can view Tape 065 to cover that material. You also should know how to solve linear equations, which can be reviewed on Tape 073. While we go through the material, be sure to take careful notes. Make sure they're accurate and correct. If there's any place you don't understand the concept that I'm going over, make a mark on your paper so that you can ask for help when you go to the lab. Also, if you have any trouble with the exercises I'll give you, be sure to mark those as well so that you can get a lab instructor or a tutor to help you when you go to the lab. Now let's begin. On this tape we have 3 objectives. Objective 1 is to translate a sentence into an equation and solve. Translate a sentence into an equation and solve. Objective 2, solve consecutive integer problems. Solve consecutive integer problems. And Objective 3, solve application problems. Solve application problems. We're going to approach this as if you are a beginner in solving equations and in doing these translations. So the sentences that we'll translate into equations are relatively simple. They may be rather boring examples, but they are intended as a jumping-off place for a very powerful tool in mathematics. Consecutive integer problems we use simply because all of us know about the integers, the numbers that we put on the number line, and we can use these as a foundation type of problem that will help us to introduce formula expressions for solving equations that we create from mathematical sentences. Our applications also are general sorts of things that have to do with concepts that all of us understand. When you go into your own discipline, your application problems will be much more specialized and much more challenging. But this tape is intended to lay a foundation for your work in your own discipline later on. To begin with, we need one more word in our translation battery, and that is for the word equals. What indicates equals in English? The equals will be indicated by is, was, or will be, present, past, or future tense of the verb to be, is equal to, amounts to, represents, or similar phrases. Anytime you see one of these in a sentence, you should translate it as the equals. Let's go right away into examples. For each of our examples, the instructions are to translate into an equation and then solve. Translate into an equation, then solve. Our first example is 3 less than twice a number is 13. Find the number. 3 less than twice a number is 13. Find the number. Notice the word is. 3 less than twice a number is 13. Is one of our key words that stands for equals. 3 less than twice a number. 3 less than. Less than is a key phrase. Remember that less than tells us to subtract in reverse. Subtract in reverse. Therefore, 3 less than twice a number would put the 3 at the end after the subtraction symbol. Twice a number, twice means 2 times. So all we need is something to represent our number. To help the reader who is going to be looking at our work, let's indicate what letter will stand for the number. So we begin by saying the number is whatever letter we choose. I have chosen the usual letter X. So my sentence will be 3 less than twice X. Twice X would be 2 times X. 2 times X precedes the subtraction sign. 3 follows it. And so my equation becomes 2x for twice a number, subtract 3 for 3 less than, is equals 13. 2x subtract 3 equals 13. We've now accomplished the first step in the solution. Translate into an equation. We have translated the sentence into an equation. Now we're ready to finish by solving. And so we have simply an equation, 2x subtract 3 equals 13. We solve this. Remember that subtract 3 means add the opposite, so add -3. To solve for x, we must remove the 3 from the left-hand side, and so we write 2x add -3, add 3 is equal to 13, add 3, adding 3 to both sides of the equation. On the left, the -3 and the +3 cancel. That is, they add up to 0, and so we get 2x. On the right, 16. So we have 2x is equal to 16. Then to get x by itself, we divide by the coefficient, which is 2. Divide both sides by 2. On the left, 2x over 2 is simply x. On the right, 16 over 2 is 8. And so our solution is x equals 8. And so we're saying that the answer to this problem is 8. Remember where we check a problem. We check a problem in the original. What's the original? Well, you might think that the original is 2x subtract 3 equals 13, but that's not where we began. We began with the words. So we should check our answer in the words. So for the check, I have rewritten the problem. 3 less than twice a number is 13, but I've written it so that the is separates the problem into 2 parts. So my check reads, 3 less than twice a number is 13. Notice that the is, the equals, is the dividing place, and I set up my usual T format for checking, with the is representing the equals mark. 3 less than twice a number. For my number, I'm using 8, and so it's 3 less than twice 8. 3 less than twice 8. On the right, I have simply 13. 3 less than twice 8 means I take the twice 8, or 2 times 8, and subtract 3 from it. On the right, it's just 13. 2 times 8 is 16. 16 subtract 3 on the left. Still just 13 on the right. And 16 subtract 3 is 13. And so the check can be built on the original, which is the words. 3 less than twice 8 is 13. Therefore, the answer that I got before, which is x equals 8, is the correct answer. Let's do another problem.